Hello there, and welcome to the My Sleep Science channel. I'm so glad you found your way here tonight. Maybe you've had a long day, or maybe you're just the kind of person who finds peace in the quiet mysteries of space rather than counting sheep. Either way, this journey is for you. Tonight, we're drifting far from home, not to another planet in our solar system, or even to a nearby star. We're traveling to meet a visitor, a wanderer from the space between stars. Its name is 3I Atlas, and though you may never have heard of it, this small cosmic traveler carries secrets that stretch across light years and time itself. You don't need to do anything now except rest. Let your shoulders soften, your breathing slow, and your thoughts begin to float. Because tonight, we're following a comet that came from somewhere else entirely, and in its quiet journey through our solar system, we'll find beauty, wonder, and perhaps a kind of peace that only the vastness of space can bring. Before we begin, if these gentle explorations help you unwind or spark a quiet curiosity as you drift towards sleep, consider liking and subscribing to the channel. It helps others find their way here too, one sleepy soul at a time. Now, let's begin our journey with a visitor from the stars. In the summer of 2023, something unusual appeared in the night sky. Not a meteor shower or a bright planet, but something far more subtle. A faint smudge of light, barely visible even through powerful telescopes, moving against the background of distant stars. At first, astronomers weren't entirely sure what they were looking at. Was it an asteroid? A comet? Another piece of debris from the early solar system? But as they tracked its motion and calculated its path, something remarkable became clear. This object wasn't from here. It didn't orbit the sun. It was just passing through. They named it 3I Atlas, and it became only the third confirmed interstellar object ever detected entering our solar system. The I stands for interstellar, marking it as a visitor from the vast darkness between stars. The 3 means it was the third such object we found, and Atlas comes from the survey system that first spotted it, the Asteroid Terrestrial Impact Last Alert System in Hawaii. Think about that for a moment. In all of human history, we've only confirmed 3 objects that came from beyond our sun's gravitational embrace. 3 visitors in all the centuries we've been watching the sky. 3I Atlas is one of them. Unlike planets or asteroids that circle endlessly around the sun, trapped in their orbits like dancers in a cosmic waltz, 3I Atlas follows a different path. Its trajectory is hyperbolic, meaning it's not bound to our star. It came from somewhere else, swung past our sun, and will continue on into the darkness beyond, never to return. When astronomers first calculated its orbit, they found something beautiful. 3I Atlas entered our solar system at a slight angle, passing through the plane where the planets orbit. It approached from the direction of the constellation Puppies, which lies in the southern sky. That means it came from a region of space far from the familiar landmarks we use to navigate the night. The speed at which it traveled told them everything they needed to know. Objects that orbit the sun move at predictable speeds based on their distance from it. But 3I Atlas was moving faster than any orbit would allow. When it reached its closest point to the sun, called perihelion, it was traveling at roughly 88 kilometers per second relative to our star. That's over 197,000 miles per hour. No object born in our solar system moves quite like that. The excess velocity, the unbound trajectory, the angle of approach, all of it pointed to one conclusion. This was an interstellar traveler, and we were witnessing something that happens only once in a generation, or perhaps even rarer. As 3I Atlas drifted through our cosmic neighborhood, it remained remarkably dim. At its brightest, it reached only about magnitude 14, far too faint for the naked eye or even amateur telescopes. You would need professional equipment and careful tracking to see it at all. And yet, despite its faintness, it captured the imagination of astronomers around the world. Because here was proof, visible and measurable, that the space between stars is not empty. It's filled with wanderers, with debris, with objects ejected from other solar systems, or perhaps never bound to any star at all. And every now and then, one of these travelers passes close enough for us to see it, to study it, to wonder where it came from, and what it might tell us about the universe beyond our home. 3I Atlas appeared as a comet, not an asteroid. That distinction matters. Comets are made of ice, dust, and frozen gases, materials that formed in the cold outer regions of a planetary system. When they approach a star's heat, these ices begin to evaporate, creating the characteristic tail and fuzzy glow we associate with comets. As 3I Atlas moved closer to the sun, astronomers watched it carefully. They saw the subtle brightening, the development of a faint coma, a cloud of gas and dust surrounding the nucleus. It was behaving like a comet should, releasing material as the sun's warmth reached its ancient frozen surface. This behavior told them something important. 3I Atlas wasn't just any interstellar object. It was a pristine sample of material from another star system, material that had been frozen for who knows how long in the cold darkness of interstellar space. And now, for a brief moment, it was warming, releasing gases, giving scientists a chance to analyze what it was made of. The composition of a comet is like a fingerprint. By studying the light reflected and emitted by 3I Atlas, astronomers could identify specific molecules in its coma. They found water vapor, carbon monoxide, and traces of other compounds. These are the building blocks of comets in our own solar system, but the ratios and abundances might differ, hinting at the conditions in the distant system where 3I Atlas was born. Where did it come from? That's harder to say. Space is vast, and stars move. Over millions or billions of years, the galaxy rotates. Stars orbit the galactic center at different speeds, and the positions of solar systems shift dramatically. Tracing 3I Atlas backward through time is possible, but the uncertainties grow quickly. Astronomers ran simulations, calculating the object's past trajectory through the Milky Way. They looked for stars or star-forming regions it might have passed near, but the results were ambiguous. 3I Atlas could have come from a star system dozens or even hundreds of light years away. It might have been ejected billions of years ago, drifting through the void ever since. Or it could be younger, flung out more recently by gravitational chaos in a newly forming planetary system. We may never know exactly which star system sent it our way, but in a sense, that uncertainty is part of the beauty. 3I Atlas is a mystery wrapped in ice and dust, a traveler with no clear home, no return ticket, and no story we can fully read. It simply is, drifting through the galaxy, and we were lucky enough to catch a glimpse. As it passed through our solar system, 3I Atlas didn't come particularly close to Earth. Its orbit kept it well beyond the inner planets, out in the region where Mars orbits. It posed no danger, no threat. It was simply passing by, indifferent to our existence, following the path carved by gravity and momentum. And then, as quietly As it arrived, it began to leave. The sun's warmth faded behind it. The activity in its coma decreased. The tail, if it had one, would have dissipated. 3i Atlas continued outward, crossing the orbit of Jupiter, then Saturn, then beyond. Eventually, it will reach the outer edges of the sun's influence, pass the heliopause, and return to the interstellar medium from which it came. It will never return. The path it follows is a one-way journey, a gentle arc through our star's gravity well that bends its course slightly, but doesn't capture it. In a few thousand years, it will be light years away, moving silently through the darkness, perhaps never coming near another star again. There's something quietly profound about that. An object that traveled unimaginable distances, moved through the emptiness for perhaps millions of years, and then briefly, just for a moment, passed close enough to a small yellow star that the beings living on the third planet from that star could see it and study it and wonder. And now it's gone. Not destroyed, not captured, just continuing on. Somewhere out there, 3i Atlas is still moving, still cold, still carrying the story of its origin frozen in its icy nucleus. And we, the lucky witnesses, sit here beneath our own sky, holding the memory of its visit like a quiet gift from the cosmos. Take a slow breath. Let that image settle. A lone traveler, older than empires, passing through our neighborhood, seen briefly, and then returning to the endless dark. In its journey, we find a kind of peace, the knowledge that the universe is full of such travelers, such quiet passages, such gentle encounters that most go unnoticed, but a few, just a few, we're able to catch. Part 2. The language of light and ice. When astronomers study something as distant and faint as 3i Atlas, they're not using their eyes. At least, not in the way you might imagine. They're using light itself as a language, reading the messages encoded in the photons that traveled from the comet to our telescopes. Light carries information, not just brightness, but color, wavelength, and intensity. When light passes through or reflects off a substance, it interacts with the atoms and molecules in that substance. Some wavelengths are absorbed, others are emitted. The pattern that remains is called a spectrum, and it's like a fingerprint, unique to the materials present. For 3i Atlas, astronomers pointed their instruments toward that faint smudge of light and collected as many photons as they could. Then they spread those photons out across their spectra, looking for the dark and bright lines that would tell them what the comet was made of. What they found was familiar and yet intriguing. Water vapor was present, as expected. Water ice is common in comets throughout our solar system, formed in the cold regions beyond the frost line where temperatures are low enough for water to freeze. The presence of water in 3i Atlas suggested that its home system, wherever it was, had similar conditions. Cold enough for ice, warm enough at some point in the past for chemistry to occur. Carbon monoxide was there too, along with trace amounts of carbon dioxide and possibly hydrogen cyanide. These are volatile compounds, meaning they evaporate easily when warmed. Their presence in the coma indicated that 3i Atlas was releasing them as it approached the sun, just like comets born in our own neighborhood. But here's what made it interesting. The ratios of these compounds, the relative amounts of carbon monoxide to water, for example, were slightly different from what we typically see in comets from our solar system. Not wildly different, but enough to suggest that the chemistry of its birthplace might have been distinct. Maybe the disk of gas and dust around its parent star had a different composition. Maybe the temperature and pressure were slightly off. Maybe it formed closer to its star or farther away than we initially thought. These subtle differences are clues. They hint at the diversity of planetary systems, the variety of conditions under which ice and rock can form. In our own solar system, we've studied dozens of comets, and while they share similarities, each one is unique. 3i Atlas adds another data point, a single comet from beyond, expanding our understanding of what's possible out there in the galaxy. Studying the light from 3i Atlas also revealed its rotation. As it tumbled through space, its brightness varied slightly, dimming and brightening in a regular pattern. This variation told astronomers that the comet was not spherical, but elongated or irregularly shaped. As it spun, different sides reflected different amounts of sunlight, creating a subtle flicker in the light we received. From these brightness changes, scientists estimated its rotation period, the time it takes to complete one full spin. For 3i Atlas, this was measured in hours, a relatively fast rotation for a comet of its size. That spin is likely a relic of its formation or the result of collisions and gravitational interactions it experienced long ago. Every tumble carries history, a record of forces applied and momentum transferred over unimaginable timescales. The size of 3i Atlas is harder to pin down precisely. Because it's so faint and so far away, direct imaging of the nucleus, the solid core of ice and rock, is nearly impossible. Instead, astronomers estimate size based on brightness, albedo, how reflective the surface is, and the activity level of the coma. Current estimates suggest the nucleus is somewhere between a few hundred meters and a kilometer or so across. Small by cosmic standards, but still a mountain of ice drifting through space. That small size is actually comforting in a way. 3i Atlas isn't a giant looming threat. It's a modest chunk of frozen material, perhaps the remnant of a larger body that broke apart long ago. Or perhaps a pristine leftover from the formation of its home system. Either way, it's small enough to feel intimate. A single snowball from another star, passing quietly through our neighborhood. The coma surrounding the nucleus is larger, of course. As the ice evaporates, it forms a cloud of gas and dust that can extend for thousands or even tens of thousands of kilometers. This coma is what makes comets visible from such great distances. The nucleus might be tiny, but the material it releases catches the sunlight, glowing faintly against the darkness of space. For 3i Atlas, the coma was never particularly dramatic. It didn't develop the long, sweeping tail that some comets display when they come very close to the sun. That's because 3i Atlas didn't get close enough. Its perihelion, the closest point in its orbit to the sun, was still well outside the Earth's orbit. At that distance, the sun's heat is enough to cause some sublimation, ice turning directly into gas, but not enough to create the spectacular outbursts seen in comets that dive closer. This subtlety is part of what makes 3i Atlas so soothing to think about. It's not a dramatic fireball tearing through the sky. It's a quiet visitor, gently releasing puffs of gas, glowing faintly, and moving steadily on its way. There's no chaos, no destruction, just a slow, graceful passage. A celestial hello, barely audible, and then a gentle goodbye. The dust released by 3i Atlas is also fascinating. Cometary dust is made of tiny particles, often just micrometers across, smaller than the width of a human hair. These particles are a mix of silicates, rocky material, and organic compounds, carbon-based molecules. When light hits them, they scatter it, creating a diffuse glow around the comet. In our own solar system, cometary dust eventually spreads out along the comet's orbit, forming streams of particles that Earth occasionally passes through. When that happens, we see meteor showers, tiny grains burning up in our atmosphere, creating streaks of light across the sky. But 3I Atlas won't leave such a legacy here. Its orbit doesn't intersect with Earth's, and even if it did, the dust would be scattered so thinly across space that it would never create a noticeable shower. Instead, the dust from 3I Atlas will join the interstellar medium, mixing with the gas and particles that fill the space between stars. Over time, it will disperse, perhaps eventually contributing to the formation of new stars and planets billions of years from now. In that sense, 3I Atlas is not just a visitor, but a messenger, carrying material from one stellar neighborhood to another, helping to remix the galaxy's ingredients. Scientists also looked for signs of activity changes as 3I Atlas moved through the solar system. Some comets experience outbursts, sudden increases in brightness, caused by the rapid release of gas and dust. These can happen when a pocket of volatile material beneath the surface is suddenly exposed, or when the comet's rotation brings a particularly icy patch into direct sunlight. For 3I Atlas, the observations didn't show any major outbursts. Its behavior was relatively calm and predictable, gradually increasing in activity as it approached the sun and then slowly fading as it moved away. This steadiness suggests a relatively uniform composition, without large pockets of especially volatile material waiting to explode. There's something comforting in that predictability. The universe, so often chaotic and violent, can also be gentle. A comet can drift through space for eons, warm slightly under the sun's light, release a bit of gas, and then continue on without drama. It's a reminder that not everything in the cosmos is an explosion or a collision. Sometimes, things just move quietly, following the laws of physics, shining faintly and passing by. As astronomers watched 3I Atlas, they also considered what it might tell us about the frequency of interstellar objects. If we've detected 3 such objects in just a few years, how many more are out there, undetected? The answer is likely billions. For every interstellar traveler we spot, countless others pass through unnoticed, too faint or too far from our line of sight. This realization changes how we think about the solar system. It's not a closed system, isolated from the rest of the galaxy. It's porous, open, constantly visited by material from elsewhere. Some of this material is large enough to see, like 3I Atlas, but much of it is smaller, dust grains, molecules, particles, flowing through like a slow breeze, mixing with our own local material, becoming part of the planets and moons and asteroids over billions of years. In that sense, we are not separate from the galaxy. We are part of it, connected by these quiet flows of matter, by the drifting ice and dust that moves from star to star. 3I Atlas is just one thread in that vast tapestry, one small piece of evidence that the boundaries between stellar systems are not walls, but membranes, permeable and ever-changing. Take another slow breath. Feel the weight of that connection. Somewhere out there, right now, 3I Atlas is continuing its journey, carrying molecules that might have come from a star you could see with the naked eye if you knew where to look. And here you are, made of material from ancient supernova, connected to that same cosmic web. Separate travelers, perhaps, but part of the same story. Part 3. The First Travelers. We knew. 3I Atlas is not the first interstellar object we've detected. It's the third. And the stories of the first two are just as fascinating, each adding its own chapter to our understanding of these cosmic wanderers. The first was Oumuamua, a name taken from Hawaiian, meaning scout or messenger. It was discovered in October 2017 by the Pan-STARRS telescope in Hawaii. And from the moment astronomers calculated its orbit, they knew it was something special. Like 3I Atlas, Oumuamua was moving too fast, on a trajectory that couldn't be explained by any orbit around the sun. Oumuamua was unusual in many ways. It was highly elongated, shaped like a cigar, or perhaps a pancake, tumbling end over end as it moved. Its surface was dark and reddish, suggesting it had been exposed to cosmic radiation for a very long time. And strangest of all, as it moved away from the sun, it accelerated slightly, more than could be explained by gravity alone. That acceleration sparked intense debate. Was it caused by outgassing, like a comet releasing jets of gas that acted as tiny thrusters? Or was it something else? Some suggested it could be a piece of alien technology, a light sail or probe sent from another civilization. Most scientists remained skeptical, favoring natural explanations, but the mystery lingered. Oumuamua passed through our solar system quickly. By the time astronomers realized what it was already leaving, moving too fast and too far for detailed study. Within weeks, it was gone, disappearing into the darkness beyond Neptune's orbit, never to return. We're left with limited data, a handful of images, and more questions than answers. The second interstellar object was 2I Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov using a homemade telescope. Unlike Oumuamua, Borisov behaved exactly like a comet. It had a bright coma, a clear tail, and showed all the signs of active outgassing. Its composition, as far as astronomers could tell, was similar to comets in our own solar system: water ice, carbon monoxide, and organic compounds. 2I Borisov was in some ways less mysterious than Oumuamua, but also more reassuring. It confirmed that interstellar comets exist, and that they can look and behave much like the comets we know. It was a familiar face, in an unfamiliar context, proof that the laws of physics and chemistry that govern our neighborhood apply elsewhere too. And now, 3I Atlas, the third confirmed visitor, continuing the pattern. Each interstellar object we detect teaches us something new, and together they paint a picture of a galaxy filled with wanderers, with debris, with small bodies moving between stars on journeys that last millions of years. What these three objects have in common is their rarity, or rather, the rarity of our ability to see them. Detecting an interstellar object requires both luck and vigilance. They're small, faint, and moving quickly. By the time we notice them, they're often already on their way out. It's like trying to spot a single bird flying through a vast forest at night. You need to be looking in the right place at the right time with the right tools. Fortunately, our tools are improving. Telescopes like Pan-STARRS, Atlas, and soon the Vera C. Rubin Observatory are designed to scan the entire visible sky repeatedly, looking for anything that moves. These surveys are automated, using computer algorithms to flag unusual objects for human review. As these systems become more powerful and more widespread, will likely detect more interstellar visitors. Some estimates suggest that at any given time, there might be several interstellar objects passing through the inner solar system. Most are too small or too faint to detect, but they're there, drifting silently past Mars, Jupiter, or even closer to Earth, unseen and uncounted. The solar system is not a quiet, empty place. It's busy, filled with traffic we're only now beginning to notice. The discovery of these objects also raises exciting possibilities for future missions. Could we send a spacecraft to intercept an interstellar visitor? The idea is tantalizing. Imagine a probe equipped with instruments to sample the surface, analyze the composition, and send back images and data. It would be like receiving a parcel from another star, opened and examined in real time. The challenge, of course, is speed. Interstellar objects move fast, and by the time we detect them, they're often already leaving. Launching a spacecraft quickly enough to catch up would require either advance warning or incredibly rapid mission design and deployment. Some scientists have proposed keeping a spacecraft on standby, ready to launch at a moment's notice when the next visitor is detected. It's a bold idea, but perhaps not impossible. For now, we rely on telescopes, on light, on the information carried by photons across the vast distances of space. And from that light, we learn. We learn about chemistry, about the diversity of materials in the galaxy, about the history of other star systems. Each interstellar object is a tiny sample, a single data point, but together they help us map the unseen universe. 3I Atlas, Oumuamua, and 2I Borisov are the beginning of a new chapter in astronomy. For centuries, we studied only what was bound to our sun, the planets, moons, asteroids, and comets that call this system home. Now, we're expanding our view, recognizing that we're not isolated. We're part of a larger ecosystem, a galactic network of matter and motion. And every now and then, a piece of that larger world passes close enough for us to touch it, if only with light. There's a certain poetry in that. We sit here on a small planet orbiting an average star, looking out into the night, and the night looks back. Not with eyes, but with travelers. Not with words, but with ice and dust. Each visitor is a message, a reminder that we are not alone, not in the sense of intelligent life, but in the sense of connection. The same elements, the same processes, the same physics that shaped us shaped them too. We are cousins, in a way, children of the same galaxy, meeting briefly under the same sun. And in those meetings, we find not just knowledge, but comfort. The universe is vast, yes, and often indifferent, but it is also full of movement, full of material, full of stories. 3I Atlas is one of those stories, a quiet one, perhaps, but no less beautiful for its subtlety. Breathe in slowly and let that thought settle. You are part of this too. The calcium in your bones, the iron in your blood, the carbon in your cells. All of it came from stars, just like the ice in 3I Atlas. You are made of the same stuff, shaped by the same forces. And when you look up at the night sky, you're not looking at something foreign. You're looking at family. Part 4, The Long Night Between Stars. To truly understand 3I Atlas, we must consider not just where it's been in the recent past, the few years or decades we've observed it, but where it's been over the vast stretches of time that came before. Because before it entered our solar system, before it brightened slightly under the sun's warmth, 3I Atlas was drifting through interstellar space. Interstellar space is not the cold black void you might imagine. It's not empty, but it's not crowded either. It's a kind of middle ground, a vast ocean with a density so low that in a laboratory, it would be considered a near-perfect vacuum. And yet, over the scale of light years, even that thin haze of atoms, molecules, and dust becomes significant. The space between stars is filled with something called the interstellar medium, or ISM. It's made mostly of hydrogen and helium, the simplest and most abundant elements in the universe, but scattered within it are heavier elements too. Carbon, oxygen, nitrogen, iron, created in the hearts of stars and scattered by supernova explosions. There are also complex molecules, some organic, drifting like microscopic ghosts through the dark. And then there's dust, tiny grains, often just a fraction of a micrometer across, made of silicates or carbon. These grains absorb and scatter light, which is why interstellar space appears dark when we look between the stars. The dust blocks visible light, but if you look in infrared or radio wavelengths, the ISM glows faintly, warmed by distant starlight or by the rare collision of particles. 3I Atlas spent who knows how long moving through this environment. Millions of years perhaps, maybe tens of millions. During that time, it was bombarded by cosmic rays, high-energy particles that travel at nearly the speed of light, zipping through space and occasionally striking the surface of a comet or asteroid. These impacts would have gradually altered the surface chemistry of 3I Atlas, darkening it, creating new compounds, and leaving subtle scars invisible to the eye but measurable in the spectrum of light it reflects. The temperature out there, far from any star, is close to absolute zero. In the depths of interstellar space, the ambient temperature is around 2.7 Kelvin, just a few degrees above the coldest possible temperature. That's the temperature of the cosmic microwave background, the faint afterglow of the Big Bang that fills the entire universe. Nothing can be colder than that, unless actively cooled by some process. And out there in the dark, there's nothing to cool further. At that temperature, most substances are frozen solid. Water ice, carbon dioxide, carbon monoxide, methane, all of them are locked in crystalline structures, immobile, silent. 3I Atlas, drifting through this cold, would have been a frozen chunk, its surface hard and brittle, its interior unchanged for eons. Time, in a sense, stopped. Without heat, without light, without the chaos of a planetary system, there was nothing to disturb it. And yet, the journey itself is a form of change. Slowly, imperceptibly, 3I Atlas moved through the galaxy. The Milky Way rotates, but not like a solid disk. Different parts move at different speeds, and stars drift relative to one another. 3I Atlas, no longer bound to any star, moved on its own trajectory, following a path carved by the gravitational influences of stars it passed near, the mass of the galaxy itself, and the initial velocity it carried when it was ejected from its home system. Imagine it. A small, frozen body, moving silently through a darkness so vast that even light takes years to cross it. No sound, no motion, relative to the background of stars, except over the longest timescales. Just cold, stillness, and the faint whisper of cosmic rays tapping against its surface like rain on a window. For millions of years, this was 3I Atlas's existence. No drama, no events, just the slow passage of time. And then, eventually, by chance, it encountered our solar system. It didn't aim for us, of course. There was no intention, no guidance. It simply happened that its path and ours intersected. Gravity did the rest. As 3I Atlas approached the sun's sphere of influence, it began to accelerate, pulled inward by the massive gravity of our star. Its trajectory bent, curving around the sun like a ball rolling past a hill. And in that moment, after eons of silence, 3I Atlas began to wake. The sun's warmth, still distant but growing stronger, started to penetrate its surface. Molecules that had been frozen for longer than civilizations have existed began to vibrate, to shift, to sublimate. Gas escaped, carrying dust with it, forming the faint coma that astronomers would eventually detect. It's a kind of rebirth in a way. Not life, certainly, but a transition from one state to another, from the frozen stillness of interstellar space to the gentle activity of a comet warmed by a star. And in that transition, 3I Atlas became visible, knowable, a part of our story for a brief time. But even as it warmed, 3I Atlas remained fundamentally unchanged. The heat from the sun only penetrated a thin outer layer, perhaps a few meters deep at most. Below that, the comet stayed frozen, untouched, a time capsule from its distant past. When scientists analyzed the gases released, they weren't just studying what 3I Atlas was made of. They were studying what the disk of gas and dust around its parent star was made of, billions of years ago, when that system was young and planets were just beginning to form. This is the gift of interstellar objects. They carry samples from other parts of the galaxy, from other times, and they deliver them to us free of charge. We don't have to travel light years to study other star systems. Sometimes, those systems send us pieces of themselves, drifting through the dark, waiting to be found. The journey of 3I Atlas through interstellar space is also a journey through time. The galaxy has changed since it was ejected. Stars have been born and died. Planets have formed, evolved, and perhaps been destroyed. The very structure of the Milky Way has shifted, spiral arms moving like slow-motion waves through the disk. And through it all, 3I Atlas drifted, unchanged, a silent witness to the galaxy's evolution. When it finally arrived here, entering the warm embrace of our sun's light, it was like a visitor from another era. Not just another place, but another time. The ice in 3I Atlas might have formed when the solar system itself was still a cloud of gas and dust, before Earth existed, before the sun ignited. It's older than our history, older than our world, a fragment of the deep past delivered to the present. And soon, it will return to that long night between stars. The brief moment of warmth and visibility will end. 3I Atlas will cross the boundary where the sun's influence fades, pass beyond the heliopause, and re-enter the cold, dark expanse of the ISM. There, it will freeze again, returning to the stillness it knew for so long. But it will be changed, however slightly. The sun's heat will have altered its surface, removed some of its ice, rearranged some of its molecules. When it drifts past another star, perhaps millions of years from now, it will carry with it a trace of our sun, a memory of its visit here. In that sense, we've touched it, however gently, and it has touched us. There's something deeply peaceful about that image. The long, cold journey, the brief warming, the return to silence. It's the rhythm of the galaxy, playing out over timescales we can barely imagine. And in that rhythm, there's no hurry, no urgency, just motion, slow and inevitable, like the turning of a wheel or the flow of a river. Close your eyes for a moment. Picture 3I Atlas, alone in the dark, moving so slowly that you could walk faster. No light, no sound, just the faint background glow of the universe itself. And then far ahead, a star begins to brighten. Slowly, over years, it grows from a pinpoint to a brilliant beacon. The comet falls toward it, speeds up, warms, glows. And then it passes, and the star fades behind, and once again, there's only darkness. This is the life of an interstellar traveler. Not dramatic, not loud, but endlessly, quietly beautiful. And in that beauty, we find rest. Part 5. What 3-Eye Atlas tells us about other worlds. Every interstellar object is a messenger, carrying information about the place it came from. 3-Eye Atlas is no exception. Though we may never know exactly which star system it originated in, we can still learn a great deal about the conditions that created it, and, by extension, about planetary systems beyond our own. Comets, whether from our solar system or another, are leftovers. They're the debris that didn't get incorporated into planets during a system's formation. When a star forms, it's surrounded by a disk of gas and dust. Over time, this material clumps together, forming larger and larger objects. Some become planets, massive enough to clear their orbits and dominate their neighborhood. Others remain small, scattered in the outer regions where the disk is thinner and colder. In our solar system, this process created the Kuiper Belt and the Oort cloud, vast reservoirs of icy bodies orbiting far from the sun. These comets are pristine samples of the material that existed when the solar system was young. They haven't been heated, melted, or differentiated like planets have. They're frozen time capsules, preserving the chemistry of the early solar system. 3-Eye Atlas likely formed in a similar way in the cold outer regions of its home system. The presence of water ice, carbon monoxide, and other volatiles tells us that the disk around its parent star had temperatures low enough for these materials to freeze. That's consistent with formation beyond the snow line, the distance from a star where water ice can exist. But the exact composition of 3-Eye Atlas offers more specific clues. The ratios of different molecules, how much carbon monoxide relative to water, for example, depend on the temperature and pressure in the disk at the time of formation. Small differences in these ratios can tell us whether 3-Eye Atlas formed close to its star's snowline or farther out in the coldest, most distant reaches. Preliminary studies suggest that 3-Eye Atlas is broadly similar to comets in our solar system, but with subtle differences. These differences might indicate that its home system had a slightly different chemical makeup, perhaps because its parent star was richer or poorer in heavy elements than our Sun. Or it might simply reflect different formation conditions, variations in temperature or density in the disk. Understanding these differences helps astronomers build better models of how planetary systems form. Every system is unique, shaped by the mass of its star, the composition of its initial gas cloud, and the chaotic interactions between forming planets. By studying interstellar objects like 3-Eye Atlas, we add data points to our models, refining our understanding of the diversity of systems out there in the galaxy. 3-Eye Atlas also tells us something about planetary system dynamics. For a comet to become interstellar, it has to be ejected from its home system. That usually requires a gravitational interaction, often with a giant planet. In our solar system, Jupiter and Saturn act as gravitational bulldozers, flinging comets out of their orbits and sometimes sending them into interstellar space. The fact that 3-Eye Atlas exists suggests that its home system likely had giant planets too. These planets, through their gravitational influence, scattered smaller bodies, sending some crashing into the star, some into stable orbits, and some, like 3I Atlas, out into the galaxy forever. This process is thought to be common, which is why astronomers believe the interstellar medium is filled with such wanderers. The speed and trajectory of 3I Atlas also provide clues. When it entered our solar system, it was moving at roughly the same speed as the Sun orbits the galactic center, around 200–250 kilometers per second, relative to the rest frame of the galaxy. This suggests it wasn't ejected with extraordinary force, but was simply released into the general flow of stars and material around the Milky Way. From this, we can infer that 3I Atlas wasn't the result of a violent event, like a close encounter with another star or a catastrophic collision. More likely, it was gently nudged out of its orbit over time, perhaps by the cumulative effect of many small gravitational interactions. Once free of its star's gravity, it drifted, carried by its own momentum and the overall rotation of the galaxy. The age of 3I Atlas is harder to determine, but we can make educated guesses. If it's similar to comets in our solar system, it could be billions of years old, formed during the early days of its system's history. The surface, weathered by cosmic rays and impacts, might look dark and reddish, similar to the Kuiper Belt objects we've observed up close. But it's also possible that 3I Atlas is younger, ejected more recently from a system still in the process of settling down. Some star systems take tens or even hundreds of millions of years to clear out their debris, and during that time, ejections are common. Without direct dating methods, which would require a sample return or at least a close-up visit, we can only speculate. What's certain is that 3I Atlas is part of a larger picture, a galaxy-wide process of mixing and redistribution. Stars form, planets coalesce, and in the chaos of those early years, material is scattered. Some of it stays local, orbiting the star in stable belts, like our Kuiper Belt. Some is ejected, becoming interstellar. And every now and then, one of these ejected wanderers passes through another system, bringing with it a sample of its distant origin. In this way, the galaxy is connected. Material from one system can end up in another, either through interstellar objects like 3I Atlas, or through more subtle processes, like the mixing of gas and dust in the interstellar medium. Over billions of years, this mixing might even influence the chemistry of new stars and planets, spreading elements and molecules across vast distances. Some scientists have even speculated about panspermia, the idea that life or the building blocks of life could be transported between star systems on comets or asteroids. While there's no evidence that 3I Atlas carries anything alive, it does carry organic molecules, carbon-based compounds that are the precursors to life. If such molecules are common in interstellar objects, they might seed new worlds with the chemistry needed for biology to emerge. It's a speculative idea, and one that's difficult to test. But it's also a beautiful thought. That life, or at least the potential for life, might spread through the galaxy like seeds on the wind, carried by frozen comets, deposited on distant worlds, and given a chance to grow. 3I Atlas, in this view, is not just a rock and ice. It's a carrier, a vessel, a messenger carrying possibility. Whether or not that's true, 3I Atlas undeniably carries information. In its composition, its structure, its trajectory, it tells us about another world, another time, another corner of the galaxy. And every piece of information we gather from it is a step toward understanding not just that distant system, but the universe as a whole. Because the universe, for all its vastness, operates on principles that are universal. The same gravity that holds Earth in orbit around the Sun governs the motion of 3I Atlas. The same chemistry that allows water to freeze on a comet allows it to exist in liquid form on our planet. The same physics that shapes galaxies shapes the smallest grains of dust. Understanding one part of the universe helps us understand all of it. And 3I Atlas, small as it is, faint as it is, contributes to that understanding. It's a puzzle piece, fitting into the larger picture, helping us see the image more clearly. So when you think of 3I Atlas, think not just of a comet, but of a teacher, a silent, patient teacher, offering lessons in chemistry, dynamics, and the deep history of the galaxy. It doesn't speak, but if we listen carefully, we can hear what it has to say. Part 6. The Future of Interstellar Visitors. 3I Atlas has come and gone, but it won't be the last. In fact, it's likely just the beginning of a new era in astronomy, one where interstellar objects are not rare curiosities, but regular guests in our cosmic neighborhood. As our telescopes improve and our survey systems become more sophisticated, we'll detect more and more of these travelers. Some will be comets, like 3I Atlas. Others might be asteroids, rocky bodies that formed closer to their parent stars. A few might be even stranger, objects we can't yet categorize, like Oumuamua, with its mysterious acceleration. The Vera C. Rubin Observatory, set to begin operation soon, will be a game changer. This telescope is designed to scan the entire visible sky every few nights, creating a constantly updated map of everything that moves. It will detect objects far fainter than current surveys can, and it will find them sooner, giving us more time to study them before they leave. With Rubin, astronomers expect to discover dozens or even hundreds of interstellar objects over the next decade. Each one will add to our understanding, expanding the sample size from a handful to a statistically significant population. We'll be able to categorize them, look for patterns, and answer questions that are currently impossible to address. For example, do interstellar comets differ systematically from those in our solar system? Are there objects that clearly formed in very different conditions, with compositions we've never seen? Do some interstellar objects show signs of having orbited close to their parent stars before being ejected, carrying heat-processed minerals or unusual compounds? The answers to these questions will reshape our understanding of planetary system formation and evolution. They'll also have implications for astrobiology, the study of life in the universe. If interstellar objects commonly carry organic molecules, as 3I Atlas does, then the ingredients for life are being distributed throughout the galaxy. Anywhere a comet like 3I Atlas crashes into a young planet, it might deliver water, carbon, and the building blocks of complex chemistry. Earth almost certainly receives some of its water from comets in the early solar system. And if our system is typical, other worlds might have been seeded in the same way. 3I Atlas. Passing through without impact is a reminder that space is full of such deliveries, happening constantly, quietly, across billions of years. There's also the tantalizing possibility of sending a mission to intercept an interstellar object. This idea has been discussed by space agencies and researchers for years. The concept is simple. Keep a spacecraft ready, equipped with instruments to study a comet or asteroid up close. When the next interstellar visitor is detected, launch quickly and rendezvous with it before it leaves the solar system. The technical challenges are significant. Interstellar objects move fast, and catching up to them requires a lot of fuel or a very clever trajectory. But it's not impossible. In fact, some mission designs propose using gravity assist from planets to gain speed, or even flying past the object at high speed to gather data, rather than matching its velocity. Such a mission would be transformative. Instead of studying light reflected or emitted by a distant object, we could see it up close, take images of its surface, measure its composition directly, and perhaps even collect samples of dust from its coma. It would be the first time humanity touched something from another star, a profound moment in our exploration of the cosmos. For now, though, we rely on telescopes. And as our ability to detect interstellar objects improves, we'll begin to build a census of what's out there. How common are comets like 3I Atlas? How many interstellar asteroids pass through each year? Are there objects that clearly formed around different types of stars, red dwarfs, white dwarfs, or even exotic systems we haven't imagined? These questions will take time to answer, but the process has begun. 3I Atlas is part of the first generation of discoveries, the early data points in what will eventually become a rich data set. And from that data set, patterns will emerge, unexpected findings will surface, and our understanding of the galaxy will deepen. There's something exciting about being at the beginning of this process. We're living in the era when interstellar objects transitioned from theoretical predictions to observed reality. For most of history, astronomers assumed such objects existed, but they had no way to prove it. Now, we can point to specific examples, track their orbits, study their compositions. We've moved from speculation to science, and the implications extend beyond astronomy. The discovery that material flows between star systems challenges the notion that each solar system is isolated. It suggests a more dynamic picture, where the galaxy is a mixing pot, with matter constantly exchanged, recycled, and redistributed. Over billions of years, this mixing might have profound effects on the chemistry of stars, planets, and even life itself. 3I Atlas, in this broader context, is not just a single comet. It's a representative of a process, a symbol of the galaxy's interconnectedness. And in studying it, we're studying not just a visitor, but the pathways that connect us to the rest of the cosmic neighborhood. As more interstellar objects are discovered, each will have its own story. Some will be pristine, ancient, untouched since their formation. Others might show signs of recent activity, perhaps ejected from a young, chaotic system still clearing its debris. A few might be truly exotic, with compositions that defy our current models, forcing us to rethink what we know. But all of them, without exception, will be travelers. Wanderers who have seen parts of the galaxy we can only dream of. And in their journeys, they carry messages, encoded in ice and dust, waiting for us to read them. 3I Atlas has already taught us much. It's shown us that interstellar comets are real, that they can be detected and studied, and that they share similarities with comets in our own system, while also possessing subtle differences that hint at the diversity of planetary systems. But its greatest lesson might be this: the universe is full of quiet motion, of gentle passages, of things that move without fanfare and exist without needing to be seen. 3I Atlas didn't announce itself. It didn't demand attention. It simply was, drifting through space, following the laws of physics, glowing faintly when warmed by the sun. And in that quiet existence, there's a kind of perfection. No drama, no urgency, just motion and time, ice and light. It's a reminder that the universe doesn't need us to observe it for it to be beautiful. It's beautiful on its own, in its own way, whether we're watching or not. But we are watching. And in watching, we find connection. We find wonder. We find a sense of place in the vastness, not through conquest or control, but through understanding. Through the gentle act of looking up, seeing a faint smudge of light, and recognizing it for what it is, a visitor from the stars, passing through and leaving us with a gift of knowledge. Take a slow breath. Feel the weight of that gift. You are living in a time when humanity can see these travelers, can study them, can begin to understand the galaxy's flows and rhythms. It's a privilege, earned through centuries of scientific progress, and it's one we're only now learning to appreciate fully. And somewhere out there, beyond the edge of our solar system, 3I Atlas continues its journey. Silent, cold, and unseen, but no less real for all that. A traveler returning to the long night between stars, carrying with it the memory of our sun, and perhaps in some small way, the memory of us. Part 7. The Poetry of Cosmic Drift. There's something deeply poetic about 3I Atlas, something that transcends the science and touches on the human experience of time, distance, and meaning. A small, frozen body, moving through the darkness for longer than civilizations have existed, encountering a star, warming briefly, and then continuing on. It's a metaphor, almost too perfect to be real, and yet it is real, happening out there right now, indifferent to our thoughts and feelings. We, as humans, live fast lives, decades if we're lucky, a century at most. In that brief span, we try to pack in as much as we can. Love, work, creativity, connection. We rush, we hurry. We feel the pressure of time always nipping at our heels. And then we look up and see something like 3I Atlas, moving on timescales that make our entire history seem like a single heartbeat. And we're reminded of perspective. The comet doesn't hurry. It can't. Its speed is determined by gravity and momentum, forces beyond its control. It moves as it must, neither fast nor slow in any absolute sense, just moving. And in that motion, there's a kind of patience, a reminder that not everything needs to be urgent, that some journeys are meant to be long, and that's okay. 3I Atlas will never know it visited our solar system. It has no memory, no awareness. It simply moves, following the invisible lines of gravitational force that crisscross the galaxy like a web. And yet, in its passage, it creates meaning for us. We see it, we study it, we wonder about it. And in that wondering, we connect with something larger than ourselves. There's a Japanese concept called mono no aware, which roughly translates to the pathos of things, or a sensitivity to the ephemeral. It's the bittersweet feeling you get when you see a cherry blossom fall, knowing it's beautiful precisely because it's temporary. The beauty is inseparable from the transience. 3I Atlas embodies that feeling. It's beautiful because it's fleeting. It passed through our neighborhood once, and it will never return. We had a few months to observe it, to gather data, to appreciate its existence. And then it was gone, back into the darkness, leaving us with only memories and measurements. That fleeting nature is part of what makes it so soothing to think about. There's no need to hold on, no need to possess or control. 3I Atlas doesn't belong to us. It never did. It was just passing by, and we were lucky enough to notice. And in that noticing, we experience something rare and precious, a connection with something utterly beyond our world. In our everyday lives, we often try to hold on to things. We want permanence, stability, security. We build homes, form relationships, create routines. And there's nothing wrong with that. It's human to want continuity. But there's also something freeing about letting go, about accepting that some things are meant to pass through our lives without staying. 3i Atlas is a reminder of that freedom. It asks nothing of us. It offers only the gift of its presence, however brief, and then it moves on. We don't need to understand everything about it. We don't need to capture it or own it. We can simply witness it, appreciate it, and then let it go. This is the poetry of cosmic drift. The slow, purposeless motion of objects through space, following no plan, serving no goal, just existing and moving, because that's what they do. There's no narrative, no story arc, no climax, just motion, cold and steady, across unimaginable distances. And yet, we find stories in it anyway. We create meaning. We draw connections. We see ourselves reflected in the journey of a frozen comet light years from anywhere. That's what humans do. We make meaning out of the raw material of experience, spinning stories from starlight and ice. 3i Atlas doesn't care about our stories. It can't. But that doesn't diminish their value. If anything, it enhances them. The meanings we create are ours alone, fragile and temporary, like cherry blossoms in spring. And in their fragility, they are beautiful. When you think of 3i Atlas now, perhaps you see more than just a comet. Perhaps you see a traveler, like yourself, moving through life on a path you didn't entirely choose, encountering warmth and light at unexpected moments, and then continuing on into the unknown. Perhaps you see a reminder to appreciate the brief encounters, the fleeting connections, the moments of beauty that don't last. Or perhaps you see something else entirely. That's the gift of poetry, of metaphor, of looking up at the night sky and finding not just stars, but stories. Whatever you see, it's yours. 3i Atlas offers it freely, asking nothing in return. In Zen Buddhism, there's a practice called just sitting, or zazen. It's a meditation where you don't try to achieve anything. Don't pursue enlightenment. Don't even try to clear your mind. You just sit. You observe what arises, without judgment, without attachment, and you let it pass. 3i Atlas is just drifting. It's not trying to reach a destination. It's not pursuing a goal. It's just moving, existing in the present moment, which for a comet lasts millions of years. There's no struggle, no striving, no anxiety. Just the simple fact of motion through space. We could learn from that, not to stop striving entirely, but to find moments of stillness within the motion, to accept the journey without needing to know where it leads. 3i Atlas doesn't know where it's going. It will drift through the galaxy until it encounters another star, or perhaps forever, never finding another warm light. And that's okay. The journey itself is enough. There's a certain comfort in that acceptance. Life is uncertain, full of unknowns. We don't know what tomorrow will bring, let alone next year or next decade. And that uncertainty can be frightening, but it can also be freeing. If we don't know where we're going, then there's no wrong path. There's just the path we're on, and the choice to keep moving forward, one small step at a time. 3i Atlas has been moving forward for eons, and it will continue for eons more. It doesn't question its path. It doesn't second-guess its direction. It simply moves, trusting in the physics of motion, in the invisible forces that guide it. And in that trust, there's a kind of peace. Of course, we're not comets. We're conscious beings, capable of choice, reflection, and change. But maybe, just maybe, we can borrow a little of that cosmic patience, that gentle acceptance of motion without destination. Maybe we can sit with the uncertainty, the not knowing, and find peace there, just as 3i Atlas finds peace in the cold, quiet darkness of interstellar space. As you drift towards sleep tonight, imagine yourself as 3i Atlas. You're moving through the darkness, carried by forces you don't entirely understand. Sometimes you encounter warmth, light, moments of brightness that make you glow. Other times, there's only the quiet, the cold, the slow passage of time. And both are okay. Both are part of the journey. You don't need to know where you're going. You don't need to have all the answers. You can just be, moving gently through the night, trusting that whatever comes next, you'll meet it when it arrives. And until then, you can rest, floating softly through the dark, at peace with the motion, at home in the vastness. This is the gift of 3i Atlas. Not just knowledge, not just science, but a kind of cosmic perspective, a reminder that we're part of something much larger, much slower, much more patient than our hurried lives usually allow us to see. And in that reminder, we find rest. So breathe slowly now. Feel yourself drifting like a comet through space. No urgency, no destination, just the gentle motion of existence. You are safe. You are held. You are part of the galaxy's slow dance, spinning through the night, glowing softly and at peace. Part 8. Where we go from here. 3i Atlas has passed through and moved on, but its story isn't over. Not for us, anyway. Every observation, every data point collected, every spectrum analyzed continues to teach us. The scientific papers written about it will be read for years, cited, built upon. Future researchers will look back at 3i Atlas as one of the early examples, a stepping stone in our understanding of interstellar objects. And beyond the science, there's the cultural impact. 3i Atlas has entered our collective imagination, joining Oumuamua and 2i Borisov as symbols of cosmic connection, of the galaxy's hidden flows. Artists will be inspired by it, writers will reference it, and educators will use it to teach about interstellar space, planetary formation, and the scientific method. In classrooms around the world, students will learn that objects from other star systems pass through ours. They'll see images of 3i Atlas's orbit, learn about its composition, and perhaps feel a spark of wonder that leads them toward careers in astronomy, physics, or related fields. The comet's influence, though it passed through quickly, will ripple outward for decades. There's also the practical impact on future space missions. The detection and study of 3i Atlas have refined our techniques for finding and characterizing faint, fast-moving objects. These same techniques will be used to detect potentially hazardous asteroids, to identify targets for future missions, and to expand our catalog of solar system objects. In a sense, 3i Atlas has made us better at looking up. We've developed new algorithms, built better instruments, and trained ourselves to recognize the subtle signatures of objects that don't belong. And that vigilance will serve us well, not just for finding interstellar visitors, but for protecting Earth from impacts and for exploring the solar system more thoroughly. Looking forward, the next generation of telescopes will detect interstellar objects at an unprecedented rate. Within a decade, we'll likely have dozens of examples to study, each adding nuance to our understanding. Some might be so distant that we barely detect them in time. Others might pass closer, offering unprecedented opportunities for detailed study. And eventually, inevitably, we'll send a spacecraft. It might take years or decades to plan and execute, but it will happen. We'll intercept an interstellar object, fly alongside it, photograph its surface, analyze its composition, and perhaps even land on it. That moment will be historic, a true first contact with matter from another star. When that happens, 3I Atlas will be remembered as part of the journey that made it possible. It will be cited in the mission proposal, referenced in press releases, and included in the historical accounts of how humanity first reached out to touch something from beyond. Not the first interstellar object we detected, but one of the early ones, part of the foundation. But even without sending a spacecraft, 3I Atlas has given us something valuable. It's reminded us that the universe is not static, not fixed in neat categories. It's dynamic, flowing, constantly exchanging matter and energy across vast distances. Stars form and die, planets coalesce and break apart, and through it all, small frozen bodies like 3I Atlas drift through the void, connecting it all in a slow, cosmic circulation. This perspective changes how we think about Earth's place in the universe. We're not isolated. We're part of a larger system, one that includes not just our solar system, but the entire galaxy. Material from other stars has fallen on Earth, carried by meteorites and possibly by interstellar objects that we didn't detect. And material from our solar system, ejected by gravitational interactions, is drifting out there somewhere, perhaps passing through another star's planetary system right now. We are connected, not by light alone, not by gravity alone, but by matter itself. The same atoms, rearranged, recycled, shared across the galaxy. 3I Atlas carries atoms that might once have been part of a planet around another star. And someday, the atoms in Earth's oceans or its rocks might drift into interstellar space, carried by a comet, ejected by Jupiter or Saturn, and become part of another world. This cycle has been happening for billions of years, since the first stars formed and died, scattering their ashes into space. And it will continue for billions more, long after humanity is gone. Long after our sun has faded to a white dwarf, long after Earth itself has been reduced to dust. The cycle doesn't need us to continue, but we are lucky enough to be here now, conscious enough to see it, curious enough to study it. And in studying it, we participate in it, not physically, not yet, but intellectually and emotionally. We reach out across the void with our instruments and our minds, touching the light from distant objects, learning their secrets, and bringing that knowledge back to share with each other. It's a form of connection, subtle but real, between us and the cosmos. 3I Atlas is gone now, drifting back into the darkness from which it came. But the impact of its visit remains, in the data it left behind, in the questions it raised, in the sense of wonder it inspired. We are richer for having seen it, even if only as a faint smudge of light, even if only for a few months. And perhaps that's the most important lesson of all. That encounters don't need to be long to be meaningful. That even a brief connection can leave a lasting impression. That sometimes the things that pass through our lives without staying are the ones that teach us the most about letting go, appreciating the moment, and finding peace in the transience of all things. As you lie here, drifting toward sleep, you are part of that same cycle. The atoms in your body were once part of stars, part of interstellar clouds, part of the solar system's formation, part of Earth's crust. You are made of ancient recycled material, temporarily arranged into the pattern that is you. And someday, those atoms will move on, becoming part of something else, continuing the cycle. But right now, in this moment, you are here. Conscious, aware, able to think about 3i Atlas, to wonder about its journey, to feel connected to something vast and ancient. That's a gift, one that's easy to overlook in the rush of daily life. But here, now, in the quiet before sleep, you can appreciate it. You can feel the weight and lightness of it at the same time. You are stardust, yes, but you're also something more. You're stardust that has organized itself into a form capable of knowing it's stardust. You're the universe looking back at itself, contemplating its own vastness and finding beauty in the simplest things. A frozen comet passing through, a faint light in the darkness, a moment of connection across the void. And in that moment, even as fleeting as it was, even as distant as 3i Atlas is now, something profound happened. You and it shared the same solar system, briefly. You orbited the same star, breathed the same solar wind, existed in the same cosmic neighborhood. And though you never saw it with your own eyes, though you'll never encounter it again, the connection is real. It's recorded in data, in spectra, in orbital calculations, but it's also recorded here in your mind as you think about it now. And in that sense, 3i Atlas isn't truly gone. It lives on in memory, in understanding, in the quiet contemplation of a universe that is both vast and intimate, both ancient and immediate. So rest now. Let the image of 3i Atlas carry you gently into sleep. A small, frozen wanderer, glowing softly in the darkness, moving ever onward, never stopping, never looking back. And you, warm and safe, drifting alongside it in spirit, sharing the same galaxy, the same moment in cosmic time. The journey continues. For 3i Atlas, for Earth, for you, each following its own path, connected by invisible threads of gravity, chemistry, and wonder. And in the morning, when you wake, you'll carry that connection with you, however faintly, a reminder that you are part of something larger, something beautiful, something that flows eternally through the stars. Sleep well, traveler. Dream of ice and light, of distance and time, of the slow, patient motion of all things through the quiet vastness. And know that wherever you go, whatever you encounter, you are part of the cosmic dance, spinning gently through the night, held by forces older than thought, guided by laws written in the very fabric of space. You are at peace. You are at home. You are, like 3i Atlas, exactly where you need to be. And now, as your thoughts grow softer and the edges of waking blur into the darkness of rest, let the story of 3i Atlas fade gently into the background, like a distant star dimming behind clouds. We've traveled together through its journey, from the cold depths of interstellar space to the warm glow of our sun, and back out into the endless night. You've learned about its composition, its path, its meaning. But more than that, I hope you've found in its story a kind of peace. The peace that comes from knowing you're part of something vast and beautiful. Something that moves slowly, patiently, without hurry or fear. 3i Atlas doesn't worry about where it's going. It doesn't regret where it's been. It simply moves, exists, glows softly when warmed, and continues on. And in that simple existence, there's a lesson for all of us. To be present, to move forward without always knowing the destination, to appreciate warmth when it comes, and to remain calm in the cold. As your breathing slows and deepens, imagine yourself as that comet one last time. You are drifting through vast, comfortable darkness. There is no rush, no urgency, just the gentle motion of existing, of being, of continuing. And in that motion, there is peace. Thank you for spending this time here, floating through the cosmos with me. If you're still awake somehow, I hope these thoughts have brought you calm. And if you're already drifting into dreams, then let those dreams be gentle, filled with starlight and ice, with distance and wonder, with the quiet beauty of things that pass through without staying. If these relaxing explorations help you unwind, consider liking and subscribing. There's always more to discover, one sleepy soul at a time. Until next time, may your rest be deep and peaceful. May you dream of travelers from distant stars, of light crossing vast distances, of connections that need no words. And may you wake refreshed, carrying with you a small piece of cosmic perspective, that reminder that we are all wanderers, all drifters, all part of the same endless, beautiful motion through the stars. Good night.